this section, you will hide annotations and dimensions in the second floor structural plan view so that sections can be placed easily. To do so, double-click on the second floor nodes under the structural plans tab in the project browser. You can see here the structural floor plan view at the second floor level is already displayed. Next, choose the View tab and then choose the Visibility Graphics tool from the Graphics tab. You can see here the Visibility Graphics overrides for structural plan's second floor dialog box is displayed. In this dialog box, choose the Annotation Categories tab. In this tab, ensure that the structure option is selected in the filter list drop-down list. Next, in the visibility column, clear the checkboxes corresponding to the dimension, structural column tag, structural foundation tags, structural framing tags, spot coordinates, and spot elevations. Then choose the OK button. The visibility graphics overrides for the structural plan second floor dialog box is closed. The next section is creating section views. In this section, you will create section and views for the project by using section tool. For that, choose the section tool from Create Panel of View tab. You can see here the modified section contextual tab is displayed. Next, in the Properties panel, ensure that the section Building Section option is selected in the Type Selector drop-down list. Then, move the cursor between the grid bubble of grid D and grid E, and then click to specify the start point of the grid line. After that, move the cursor horizontally across the building model till you have crossed the vertical grid 5.1. Click at the desired point to specify the endpoint of the section tab. The section view is created and the name Section 1 is displayed in the Sections Building Sections tab in the project browser. After that, in the Properties palette, scroll the palette if required and then click in the value field of View Name parameter under the Identify Data area and enter Section X to replace the existing value. After that, click in the value field corresponding to the title on sheet parameter under the Identify Data area and enter Sectional View Longitudinal Limit. Next, in the Properties palette, click in the value field corresponding to the Detail Level parameter under the Graphics area and select Define option in the drop-down list displayed. Next, click in the value field corresponding to the File 3 parameter under the Extremes area and enter the value 25. Then choose the Apply button in the Properties tab. Now, choose Speed segment from the section panel of Modify Views Contextual tab. You can see here the pencil mark appears in the place of cursor. Then, place the cursor over the section line. The section line gets highlighted. Next, click over the section line at the intersection with the grid 4. Click on it. As you move down the cursor toward the right, you can see the speed section line also moves. Then place the cursor along with the speed cursor line at grid F and T. The section line is displayed. You can see here the section view is created and the name Section X is displayed under the section Building Section head in the project browser. After that, repeat steps to create a transfer section view of the building model and then name the view as Section Y and the title for the sheet as a sectional view transfer and then set the File 3 offset parameter to 45 feet. Next, double-click on the name Section X to display the corresponding section view on the drawing window. Similarly, double-click on the name Section Y to display the corresponding section view in the drawing window. Now, we are going to see the next section, that is creating framing elevation views. In this section, you will create the elevation views for the project using the Framing Elevation tool and the Building Elevation tool. To create the framing elevation views, double-click on the second floor node in the Structural Plans tab of Project Browser. After that, invoke the Framing Elevation tool under the Elevation drop-down of Create Panel in the View tab. You can see here, the Modify Frame in the Elevation Contextual tab is displayed. After that, place the cursor over grade C. You can see here the grade C is highlighted. And then an elevation symbol is also displayed. Note that the elevation symbol will flip above and below the grid line as you move the cursor. Next, move the cursor slightly below the grid C, such as elevation symbol is displayed below the highlighted grid line. Next, move the cursor toward right and place it at the location and then click. The elevation tag is added. Also, an elevation view is created and added under the elevation building elevation heading in the project browser. Press Escape and then select the arrow here of the elevation tag just added. You can see here the Modify Views Contextual tab is displayed. Then, in the Properties panel, click in the value field corresponding to the view name parameter under the Identify Data head and enter Elevation GRC and then choose Apply. Press Escape twice to exit the current selection. After that, repeat steps and create an elevation at grade 3.1 and then name it as Elevation GR 3.1. Then double-click on the Elevation GRC under the Elevation Framing Elevation node in the project browser to display elevation view. And then double-click on the Elevation GR 3.1 to display its corresponding view. Then the next section is generating the graphical column schedule. In this section, you will create the graphical column schedule for the column and the quantity schedule for the columns using the graphical column scheduling tool. To do so, invoke the graphical column schedule under the schedules dropdown in the Create panel of the View tab. You can see here the graphical column schedule is displayed in the drawing area. Then, in the Properties panel, select the checkbox corresponding to the Group Similar Locations parameter under the Graphics area. You can see here the columns at the similar grid lines are grouped and displayed in the schedule. Now, click in the View Scale parameter under the Graphics area and then select the desired option from the drop-down list displayed. Now you can see here the viewing scale of the graphical column schedule is changed. Now, the next section is generating a quantity schedule for columns. In this section, you will create a schedule for displaying the quantity columns and then associated properties used in the project. To do so, invoke the Schedule Quantities tool under the Schedule dropdown of Create panel in the View tab. You can see here, new schedule dialog box is displayed. In this dialog box, select the Structural Columns option from the Category List box. And then choose OK button. You can see here, the Schedule Properties dialog box is displayed. Then, in the Available Fields list box, select the Count option. Now, press and hold the Control key and select the options from the list box such as Base Level, Family and Type, Length, and Volume. Next, release the Control key and choose the Add Parameter button. The selected options are added to the Schedule Field list box. Then, click on the Family and Type option in the Schedule Field list box and choose the Move Parameter Up button till the option comes at the top in the list. Then, repeat steps to reorder all the options in the Schedule Field list box. After that, in the Schedule Properties dialog box, choose the Sorting Grouping tab and then select the Family and Type options from the Sort By drop-down list. Ensure that the Ascending Radio button is selected. Then select the header and the footer checkboxes and then ensure that the title, count, and totals options are selected in the drop-down list next to them. Then choose the Grand Total checkbox and ensure that the item-wise every instance checkbox is selected. After that, choose the Formatting tab And then in the field list box, select the count. Next, select the Calculate Totals option from the drop-down list below the Show Conditional Format on Sheet checkbox. Then, repeat last step and select the Calculate Totals checkbox for the length and column option in the field list box. Then choose OK button. The structural column schedule is displayed. Finally, we are going to save the project. In this section, you will save the project by using the Save As tool. To do so, go to the File menu and select Project option from the Save As menu bar. The selected project file with a schedule opens in the drawing window. Now, the next section is creating a camera view. In this section, you will create a camera view for the commercial complex project. The camera view will be created at a height of 5 feet 6 inches from the entry level of the project. To do so, double-click on the entry node of the structural plan C in the project browser. Then, invoke the camera tool under the 3D view drop-down from the Create panel of View tab. You can see here the options for inserting the camera are displayed in the options bar. Next, in the options bar, ensure that the perspective checkbox is selected and enter the value 5 feet 6 inches in the offset edit box and press enter. Then move the cursor down and click at the position between the west and south elevation arrows to specify the camera location. After that, move the cursor between grid G, G1, 2, and 3 and press enter. You can see here the project view gets changed into 3D view. In this view, ensure that the crop region of the 3D view is selected and the drag controls are displayed. Next, use the drag controls to increase the extent of the view so that entire structural model is visible inside the crop region. Then, ensure that the crop region visible is selected in the Properties tab. After that, click in the value field of the view name parameter and enter camera view image to replace the existing value. Similarly, click in the value field of the title of sheet parameter and enter perspective view and choose apply button. Now, we are going to proceed with the next section, generating shadows. In this section, you will adjust the sun settings and generate shadows of the structural model displayed in the camera view. To do so, ensure that the camera view is displayed in the 3D view from the project browser. Then, choose the Visual Style Wireframe button from the View control bar. You can see here a flyout is displayed. Next, choose the Hidden Line option from the flyout display. You can see here the hidden line view of the structural model is displayed in the drawing window. Next, choose the Sun Path Off button from the View control bar. A flyout is displayed here. In this flyout, choose the sunsetting option. The sunsetting options dialog box is displayed here. In this dialog box, select Steer Radio button in the solar study area. Then, in the settings area, ensure that the location parameter is set to Boston, MA. Next, make sure that the ground plane at neighbor checkbox is selected in the sun setting dialog box. After that, select the entry option from the drop-down list displayed below the checkbox. Then, choose the Apply button and the OK button. The sun setting dialog box is closed. In the View control bar, choose the Shadow Off button. You can see here the shadow is generated in the structural model. Then, the next section is creating the sheet. In this section, you will create a sheet in the project. To do so, choose the Sheet tool from the Sheet Composition panel of View tab. You can see here the New Sheet dialog box is displayed. In this dialog box, choose the Load button. The Load family dialog box is displayed here. In this dialog box, select the specified title block C17 by 22 horizontal from the US Imperial under the title blocks folder. Then choose the Open button from the Load Family dialog box. On doing so, the specified title block is added to the list in the Select Title Blocks region of the New Sheet dialog box. Then choose the OK button to create a sheet view by using the Loaded Title block. You can see here the added sheet is now displayed in the drawing window. Now we are going to proceed with the next section, adding project views to the sheet. In this section, you need to add the specified project views to the sheet by dragging their name from the project browser. Further, based on the sheet layout, you need to place the project views at their designated place in the sheet. To do so, click on the Entry node under the Structural Plans head of Project Browser. Next, in the Properties panel, click in the value field corresponding to the view scale parameter and select 1 by 16 inches option from the drop-down list display. Now, press and hold the left mouse button on the entry node in the project browser and then drag the view into the drawing sheet. After that, release the left button where the project view appears as a rectangle in the sheet. Then, move the cursor to the lower left area of the title block such that the corner of the rectangle gets close to the lower left corner of the drawing sheet. Next, click to place the view. The entry structural plan view is added to the sheet and appears enclosed in the rectangle. Next, ensure that the viewport of the entry structural plan view is selected in the sheet. Then, in the Properties panel, ensure that the checkbox corresponding to the crop region visible parameter is clear. Then, choose the Edit Type button in the Properties panel. The Type Properties dialog box is displayed. In the Type Properties dialog box, select the Title Only option from the Type drop-down list. And ensure that the checkbox corresponding to the Show Extension Line parameter is clear, and then choose the OK button. After that, right-click in the drawing, and then choose the Active View option from the shortcut menu display. Now, in the project view, click on the North Elevation arrowhead and right-click. The shortcut menu is displayed. Then, choose the category option from the Hide in View dropdown. Again, right-click and choose the Pan Active View option from the shortcut menu display. You can see here a move icon is displayed with the cursor. Then, in the sheet, press and drag the entry structural plan view and then place it at the location. Next, right-click and choose the Deactive View option from the shortcut menu display. Then click on the camera view mode under the 3D view head of the project browser and drag it to the sheet. Next, release the mouse button and click at the location to place the camera view. After that, click on the North node under the Elevations Building Elevations head and then specify the value of view scale parameter to 1 inches equal to 10 feet. Next, drag the North node from the project browser and place it at the location. You can see here the 3 views are added to the sheet. Now, the last section of this tutorial is adding hosted area node. In this section, you will add a hosted area node to the structural floors. To do so, we need to invoke the 3D tool from the Create panel of View tab. You can see here the 3D view is displayed on the drawing window. After that, choose the Visual Style wireframe button from the View control bar. A flyout is displayed. Next, choose the Hidden Line option from the flyout display. You can see here the hidden line view of the structural model is displayed. Next, to create an analytical model, the right-click on 3D node under the 3D view head of the project browser. Then, choose the Duplicate option under the Duplicate View dropdown. After that, enter the view name as 3D Analytical Model. Next, to add the hosted area row, we need to convert the physical model into structural analytical model. To do so, invoke the Analytical Automation tool under Structural Analytical Model panel of Analyze tab. You can see here the Analytical Automation dialog box is displayed. In this dialog box, choose the Physical to Analytical for Buildings option. After that, choose the Select button from Inputs area. Then select the 3D model. After that, invoke the Filter tool under the Selection panel. We can see here the Filter dialog box is displayed. In this dialog box, click in the Levels checkbox to clear it out, and then choose the Apply button and OK button from Filter dialog box. And then choose the Run button from Analytical Automation dialog box. Next, choose the Loads tool under the Structural Analytical Model panel of Analyze tab. You can see here the Modify Point Load on Endpoint Contextual tab is displayed. After that, choose the Area Load tool under the Loads panel. You can see here the On Host tool under the Area Loads panel is selected by default. Then, to hide the physical model, invoke the Visibility Graphics tool under the Graphics panel of View tab. You can see here the Visibility Graphics overrides for 3D View, 3D Analytical Model dialog box is displayed. In this dialog box, choose the model categories and then click on the Show Model Categories in this View checkbox and then choose Apply button and then OK button. After adding the hosted area loads, we are going to save this project file. To save this file, go to the File menu, click on it, and then choose the Project option from the Save As menu bar. You can see here the selected project file opens in the drawing window. Then the next section of this tutorial is setting the analytical model. In this section, you will set analytical model by using the Analytical Automation tool. To do so, double-click on the 3D node under 3D View Scale. You can see here the 3D view of the model is displayed on the screen. Then, right-click on the View cube. You can see here the shortcut menu was displayed. From the shortcut menu, select Southwest Isometric options under the Orient to Patternization drop-down list. You can see here the Southwest Isometric view is displayed on the screen. Then go to the Analyze tab and click on it. Then choose the Analytical Automation tool of Structural Analytical Model panel. You can see here the Analytical Automation window is displayed. In this window, choose the Physical to Analytical for Buildings option. Here, the Analytical Automation window displays the various options for setting the analytical model. Then choose the Select buttons and select all the elements in the model by window selection. Next, in the display window, make sure that the Adjust Analytical Elements to Nearest Level is set to True. Then, keep all the default values and choose Run button. The software will run to set the analytical model. Then close the Analytical Automation window and press Escape to exit from the selection. Then the next section is adding boundary conditions. To add the boundary conditions, go to the Analyze tab and choose Boundary Conditions tool from Structural and Analytical Model panel. You can see here the Modify Place Boundary Conditions contextual tab is displayed. Then choose the Area tool from the Boundary Conditions panel. Then move the cursor toward the left wing of the structural model and place it at the edge of the structural floor. Next, click when the edge is highlighted. You can see here the boundary conditions are added to the slab. Similarly, add the boundary conditions to the structural floor of the right wing of the structural model. This model shows you the boundary conditions added to the structural floor of the both wings of structural model. Then press Escape to exit. Then we are going to see the next section, that is adding area reinforcement. In this section, you will add area reinforcement to the structural floor of the left wing of the structural model. To do so, double-click on the second floor node under the structural plan set. Then place the cursor at the edge of the structural floor and click when edge gets highlighted. You can see here the Modify Floors contextual tab is displayed. In this tab, choose the area reinforcement tool from the reinforcement panel. You can see here the Revit message box is displayed on the screen. Then choose the OK button in Revit message box. The Modify Create Reinforcement Boundary contextual tab is displayed. In this tab, ensure that the rebar line tool is chosen in the Draw panel. Then choose the rectangle tool from the list box in the Draw panel. Then place the cursor at the grid intersection 9 and C and click when the endpoint object snap is displayed. Then drag the cursor down and place it at the grid intersection A and D. Then click when the endpoint object snap is displayed. You can see here the magenta colored rectangular boundary is created on the screen. Then choose the Finish Edit Mode button under the More panel. Then in the Properties palette, click in the value field corresponding to the top measure bar type parameter and select File option from the drop-down list displayed. Similarly, click in the value field corresponding to the bottom measure bar type parameter and select the File 6 option. Then choose the Apply buttons. Then choose the Modify tool from Select panel. You can see here the area reinforcement is created in the structural flow. Then, to give the reinforcement added, we need to create a section. To do so, go to the View tab and choose Section tool from Create panel. Then, draw the section line in the second floor now. You can see here the section is created under the Sections view with the name Section 1. Then rename this Section 1 with Section X. Then to view the reinforcement added, double-click on the Sections X node under the Sections area. Then zoom in the floor place in the second floor level of the left wing. You can see here the reinforcements added become visible. In the next section is adding fabric area reinforcement. In this section, you will add fabric area reinforcement to the structural floor of the left wing of the structural model. To do so, double-click on the roof node under the structural plan cell. Then go to the Structure tab and click on it. Then choose Fabric Area from Reinforcement path. Then select the structural floor to the left wing of the structural model. You can see here the Modify Create Fabric Boundary Contexture tab is displayed. In this tab, ensure that the boundary line is chosen in the drawpan. Next, choose the Rectangle tool from the list box in the drawpan. Then place the cursor at the green intersection 9 and C. And now drag and place the cursor at the grid intersection A and click on it. You can see here the magenta color rectangular boundary is created. Then choose the Finish Edit Mode button from More panel. You can see here the fabric area reinforcement takes turn on the structural floor. Then choose the Modify tool from Select panel to exit the tool. You can view the area reinforcement in the structural plan view as well as in the 3D view of the structural model. Then the last section of this tutorial is saving the project. In this section, you will save the project by using the Save As tool. To do so, go to the File menu, click on it, and choose Project option from Save As menu bar. You can see if the Analytical model is open with the Analytical model 3D view. Then we are going to see the next section, that is setting the load scaling display and boundary conditions. In this section, you will set the display scale of the load and specify the boundary conditions. To do so, go to the Analyze tab. Click on it and choose Load Scaling Display tool from the Structural Analytical Model panel. See, here the Structural Settings dialog box is displayed with the Load Scaling Display tab tool. Then, in this dialog box, select Use Project Settings checkbox under the Define Generate Load Scale area. Next, choose the Boundary Conditions Settings tab. The options in these tabs are displayed. Then in the family symbol area of the boundary conditions settings tab, type 2 inches in the area and line symbols facing edit box to replace the existing value. Now choose the OK button. The structural settings dialog box is closed. Then the next section is sending the model to Robo Structural Analysis software. In this section, you will send the model to Autodesk Robo Structural Analysis Professional 2024 software. To do so, choose the Analytical Model view under 3D Views node of the project browser if the current view is different from the Analytical Model view. Here, the Analytical Model view is already open on the screen. Then choose the RoboStructure Analysis link from the RoboStructure Analysis dropdown. On doing so, the integration with RoboStructure Analysis dialog box is displayed on the screen. In this dialog box, ensure that the same model and the direct integrations review buttons are selected. Then choose the same options button. See, here the integration with RoboStructure Analysis same option dialog box is displayed. In this dialog box, keep the default settings and then choose OK button. The integration with RoboStructure Analysis same options dialog box is closed. Then choose OK button. The integration with RoboStructure Analysis dialog box is closed and the same model to RoboStructure Analysis window is displayed. This window displays the status of the file transfer and it automatically closes on the completion of the file transfer process. Once the file transfer process is complete, the integration with the RoboStructure Analysis window is displayed. Then choose the No button from this window. The window is closed and the model is displayed in the RoboStructure Analysis Professional 2024 software. If the RoboStructure Analysis is already running, then the runtime error will occur. So make sure you close the RoboStructure Analysis software. Then we are going to see the next section, that is calculating and viewing results. In this section, you will calculate the results in RoboStructure Analysis software. To do so, change the current view of the model to the top view by using the View view. Then select the Load Types option from Load menu. The Load Type dialog box with a list of load cases is displayed on the screen. Then choose Close button and then go to the Analysis tab and choose Calculations tool. The Autodesk RoboStructure Analysis Professional Calculation window is displayed. Note that this window displays the calculation status and is automatically closed when the calculations are completed. After performing calculations, go to the Results menu and choose Detailed Analysis tool. You can see here the view is changed to the Detailed Analysis and the Detailed Analysis dialog box is displayed. See, in this dialog box, the MTM tab is chosen by default. Now, select FX, FY, and MZ checkboxes from Forces area, and MX, MY, and MZ checkboxes from Moments area. Then choose the Stresses tab in the Detailed Analysis dialog box. Then choose the Maximum S Max and Minimum S Min checkboxes from the Normal Maximum area. Then choose the Apply button. See, here the detailed analysis window is displayed, showing the graphs for the forces and the moments analysis. Then choose the Close button from the detailed analysis dialog box. The dialog box is closed. Then we are going to see the next section, that is preparing results. In this section, you will prepare results of analysis. To do so, go to the Analysis menu and choose Prepare Results tool. See, here the Prepare Results dialog box is displayed. Then choose the Browse button next to the template dropdown. See, here the composition of template for result preparation dialog box is displayed. In this dialog box, enter the analytical model in the template edit box. And then choose Save button and then Close button. The changes are saved and the composition of template for result preparation dialog box is closed. Then choose the Run Preparation button in the Prepare Results dialog box. And then choose the OK button. The Prepare Results dialog box is closed. Next, go to the File menu and choose Save option. The Save as dialog box is displayed on the screen. In this dialog box, save the result at an appropriate location. So, I am browsing the C drive. Then select the RSD 2024 folder. Then select C10 RSD 2024 Tube subfolder and open it. And then choose Save button. Then we are going to see the next section, that is updating Revit model. In this section, you will update the model in Revit. To do so, switch to Revit software and then choose Reinforcement Code Check tool under RoboStructure Analysis dropdown. You can see here the reinforcement design message box is displayed on the screen. Then choose OK button. After performing the reinforcement design for beams, columns, and straight footing, the reinforcement design dialog box is displayed on the screen. Then choose OK button. The dialog box is closed. After sending the data to beams, columns, and straight footing, the warning list dialog box is displayed on the screen. After that, choose Close button. The warning list dialog box is closed. Next, choose the RoboStructure Analysis link tool from the RoboStructure Analysis dropdown. The integration with RoboStructure Analysis dialog box is displayed. In this dialog box, choose Update Model and Results and Direct Integration radio buttons under the directions of integrations with Autodesk RoboStructure Analysis and type of integration areas respectively. Next, choose the Update Options button. The integration with RoboStructure Analysis Update Options dialog box is displayed. Then choose OK button. The integration with robo structure analysis update options dialog box is closed. After that, choose OK button. See, here the same results to repeat dialog box is displayed. Then choose OK button. You can see here the update message is displayed in the integration with robo structural analysis message box. Then choose Yes button. The warning list message box is displayed on the screen. Then choose the Close button to close the message box. The model is updated and is saved. Then the last section of this tutorial is saving the project.